Hi, this is the first in a series of videos intended to help you learn vector mathematics. As you'll see as you study this and watch these videos, vector math is based on right triangle trigonometry. So see this slide here with all these equations and things. This is something you should have studied before, and if you're rusty on this, make sure that you review this so that you can use these ideas for vector mathematics. All right. So the first thing we're going to learn how to do is how to convert a vector from the magnitude angle form to vector components form. So if you read this problem, you'll see that there's a vector r with an arrow on top of it, the bold type with the arrow, that means a vector. And it's been specified in this problem as having a magnitude, here it is, and a direction, 38 degrees north of east. Now the magnitude can be is just the length of the arrow, and it's a scaled version that represents for a position vector like this how long it is from the start to the finish. And it can be written in two ways, right? So you see it can be written as the absolute value of the vector, or you can just take the arrow off, remove the bold, and these two things mean the same thing. Okay, so we are told that the vector length is equal to 15 kilometers, and that's written here. And we are also told that there's a angle that is made 38 degrees north of east, and that is here. We're going to go ahead and see how to figure out how to plot this vector if it wasn't given for us first. So let's go ahead and draw a nice coordinate system. First thing you ever want to do when you have a vector given an angle magnitude form is plot it in a graph. So we've got a nice XY coordinate system we can use here now. Now to go ahead and figure out which quadrant this vector is in, I need to look at the cardinal direction that's given here, 38 degrees north of east. So what I need to do is label the directions, okay? So we know that up is north, down is south, and to the left is west, and to the right is east, right? All right, so if we go ahead and write this direction, 38 degrees, and a short way of writing that is north of east, you actually read this backwards. Start at the east direction and then move 38 degrees towards north. So I'm going to start here, and I'm going to go ahead and move 38 degrees in the direction towards north. So we've got here our 38 degrees. And now I need to draw the magnitude, the length. We know that this is 15 kilometers here. So I gotta go and just draw this thing here, 15 kilometers. Let's label our vector r. The hypotenuse here of a triangle is 15 kilometers. And then we can make components of this vector. So I've got a right triangle I can form here at the base of the vector, and here it is. So now I've got two sides of a right triangle, right? This is a 90 here, and what we do is we call the side of the triangle that's parallel to the x-axis, we call it the x component, and this will be Rx, and the component that is parallel to the y-axis, we call it Ry. And our goal is to figure out what is Rx and what is Ry, okay? So let's go ahead and see if we can do that here. It turns out this is nothing more than a right triangle, right? If we draw this triangle over here on the side, it looks like this, right? 38 degrees. We've got a hypotenuse, 15 kilometers, and we've got the Rx and the Ry. We're going to use trig to figure these things out, okay? So recall that this is the hypotenuse, right? This is the adjacent side, and this is the opposite side, right? So we'll use the trig functions to calculate Rx and Ry. And let's start with Rx. We know that for trig, the cosine function is defined as adjacent over hypotenuse, right? Looking at our triangle, we see that for cosine of the angle 38 degrees, the adjacent side is Rx, and the opposite is the hypotenuse is 15 kilometers. Algebraically solving for Rx here, we will find out that that's equal to 15 kilometers multiplied by cosine of 38 degrees. And when we put that into the calculator, we end up getting 11.8 kilometers. Similarly, for r sub y, we can use the sine function. Recall sine theta equals opposite over hypotenuse. In this case, sine of 38 degrees is equal to ry divided by the hypotenuse, 15 kilometers. And when we solve for ry, similarly, we'll end up 15 kilometers multiplied by sine of 38 degrees is equal to 9.23 kilometers. So we've solved for a few things here now, but we're not done yet. We need to figure out what the directions of what the signs of the components are. And so the components depend on which quadrant you're in. So let's recall that this is the first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. And so the components here in the first quadrant, they're both positive. So I need to put those in by hand, positive signs. And now we've solved for the x and y components of r. There's a few other ways to write these. I can also write it like this. I can say the vector r is equal to plus 11.8 kilometers, x with a hat on it, plus 9.23 kilometers, next to a y with a hat on it. Again, these things here, these are just simply the x component, and this indicates that it's x. This is the y component, and this indicates that it's y. So it's just two different ways to write it. Now, finally, there's another way to write this, which is my favorite way, and I think it's the most useful, is just do it like this. Here's our vector. Go back to black here. Here's our vector r, and I'm just going to make a little table here. So here's the x column, here's the y column, and I'm going to put a positive 11.8 kilometers and a positive 9.23 kilometers here. So if we zoom out, then we see we can have 1, 2, or 3 different ways to write out these vector components, and it's free for you to choose how you like to do it. All right, I've readjusted things a bit here because I want to show you the quick way of figuring out vector components, because you're going to do this a lot in this class and you want to get quick at it. So let's show something real quick here. So I'm going to go ahead and use the table format. So I got vector r, and what I'm trying to do here is figure out the x and y components, right? So here's my x, here's my y. Now let me show you a quick three-step method for doing this. Usually I put my r right below here. So I'm going to look at 3 things. Rx, it's going to be, I need to choose the plus or minus sign, and then I need to put the hypotenuse next. We know this is 15 kilometers. And then that's always followed by a trig sign. So here's the third step. I need to look at the triangle and ask, look at Rx for the angle 38. Is it adjacent or is it opposite? If it's adjacent, it's cosine. And we see that it's cosine, it's adjacent, so we just write cosine 38. And we got to check and see. First quadrant, so it's going to be the plus sign. So that's your 1, 2, 3 steps. Pick the sign from the picture in the quadrant, write down the hypotenuse, and then look at the picture of the triangle and figure out, is it cosine, is it sine? All right. We go ahead and put those things in, and we get the exact same answer that we had before, right? Now for the other one, same thing, ry. I got to choose plus or minus. Well, if it's first quadrant, we know that's positive for y. Then comes the hypotenuse. And then look at the picture. For y, it's opposite of 38. That means we're going to be using the sine function. And again, when we write that down, we're going to get the answer that we had before, plus 9.23 kilometers. So practice this quick method of doing it, and it'll save you a lot of time. Okay, let me show you something else here about doing the components. If we look back at the graph, we'll see that there's another triangle that we can actually draw that's a right triangle. There's always two. So I get the purple one, but I can also draw this one. And then in that case, I'm going to be labeling, this is parallel to the y-axis, that's ry. This top part is parallel to the x-axis, that's rx. If I draw that triangle over here, I'm going to get this. And I know that the complementary angle here is going to be 52 degrees. So I could also think of this as a 52 degree angle. And here's my right angle, here is my ry, here is my rx. How would we specify this angle in cardinal direction notation? Well, we have to start here at north, and then we need to move 52 degrees towards the east, right? So this angle could also be specified as 52 degrees east of north. Remember that it always goes backwards, right? Start north, move east 52 degrees. Good. Now if I use this new triangle, I'm going to get the exact same answers as I got before. So you're always free to choose this here. And let's just look at it real quick. So here's our vector r. Here is rx, so I'm going to choose plus for first quadrant. I'm going to put in the hypotenuse here, 15 kilometers, step 2. And now I'm going to do Rx. Let's look at Rx. For 52, it's the opposite side, so we're going to use sine here. Whoops. 52 degrees is our angle. And for y, 3 steps. First quadrant, positive. Next comes the hypotenuse, 15 kilometers. Look at the y. It's the adjacent side. It's touching the 52, so that's going to be cosine in this case. If we calculate these, we're going to get the exact same numbers as we got before. So you've got 2 different ways to make your triangles here. And it's always up to you. You get the choice to do it how you like. Okay, finally, one last thing about angles. So we just found out that 52 degrees east of north is the same direction as 38 degrees north of east. So there's more than one way to specify that direction. Now let me give you another common way that we do it. So if I draw my x and y coordinate system here, so plus x plus y, another way to do this is to use the unit circle where this is 0 degrees, 90 degrees, 180 degrees, and 270 degrees, right? So we see how the north, south, east, west can also be labeled in degrees. And if we go ahead and draw our vector again here, here is vector r, right, with its 15 kilometers, and its angle here, 38 degrees. Well, I can also specify this as a positive, as a positive angle starting from the positive x direction at 0 and moving counterclockwise, so like this. In this case, we also say that this same direction is equal to theta equals 38 degrees counterclockwise from the plus x axis. I'll show you another example here. Let's say we have a different vector over here that makes an angle of, say, 25 degrees. Well, how is that one going to be specified in this way, counterclockwise from plus x axis? Well, it's the same as before. We're going to go ahead and start at the plus x axis, 0, 90, 180. 180 plus 25, that's going to be 205, right? So for this vector, the angle 205 degrees counterclockwise from plus x.